Example number 62. Given that a is a positive integer greater than 0, solve the equation log x to base a is equals to log x plus 20 to base a squared. So to solve a logarithmic equation, we must have the same base, isn't it? Are we together? So this base a squared, we have to take it to base a. Okay? We have to take it to base. So remember, if you have log b to base a, that is the same as log b over log a. The base is the logarithm denominator, isn't it? So here, if you have log x plus 20 to base a squared, that simply means you have log x plus 20 over log a squared. See, that is what it means. So you can see the power is written as the coefficient, isn't it? The power is expressed as the coefficient. So you have log x plus 20 over 2 log a. Are you seeing that? So what do we get here? Here it means we have 1 over 2. Then log x plus 20 over log a means what? It is log x plus 20 to base a. That is log x plus 20. So this is 1 over 2. You factorize outside, isn't it? So it means here we have log x to base a is equals to a half log x plus 20 to base a. So we've removed square there, isn't it? By using this logarithm. The square becomes the coefficient, then you remain with the log x plus 20 over log a is log x plus 20 to base a, isn't it? Are we together? Okay? Now, having found that we now have the same base on either side of the equation, we get rid of the coefficient, isn't it? When you get rid of the coefficient, you get log x to base a is equals to log x plus 20 to power a half then to base a. This a half is the power, isn't it? Are we together? See, after you ensure you have one term on either side of the equation, this is a single term, this is a single term, you now ignore the logs, isn't it? You ignore that? So after ignoring the log, you found x is equals to x plus 20 raised to power a half. So how do you get rid of this power half? You multiply both sides of the equation by 2, isn't it? Are we together? So that you get x squared is equals to half goes with the 2, then you remain with x plus. So are you seeing this is now quadratic? You bring this on the other side of the equation, isn't it? So we have x squared minus x minus 20 is equals to 0. So tell me, which numbers gives you a product of negative 20 and a sum of negative 1? We check if factorization 1. The numbers are 5 and 4, isn't it? Which one is negative? For you to get negative, 5 is negative, isn't it? So it is positive 1 negative 5. Good. So we have x squared plus 4x minus 5x minus 20 is equals to 0 if you're using factorization, isn't it? So the first term here we have x into x plus 4, then here the common factor is negative 5, isn't it? So if you move negative 5 outside, you remain with x plus 4 is equals to 0. Negative 5 times positive 4, you get back your negative 20, isn't it? Are we together there? So having that done, what does it imply? So we have x minus 5 and x plus 4 is equals to 0. So it means either x minus 5 is equals to 0 or x plus 4 is equals to. So x is equals to what? The first solution of x is positive 5, isn't it? The next solution of x is negative 4. Because these logarithms are not absolute value, meaning the negative solution is undefined, isn't it? Are we together? So we get the solution of x to be what? To be 5. Is that okay? So you found x is 5, and you have handled that problem.